Hello everyone. In today's video, we are basically going to learn that how we can design a 2:1 multiplexer by using basic gates, right? So for making this, at first we have to understand that what a 2:1 multiplexer basically is. Okay. So at first, for understanding that, let's make a diagram for this. Suppose here I am having two inputs, okay, that is I1, I0 and I1, right? Here we are having two inputs whose names are I0 and I1. But the case is there are two inputs, but at a time we can have the output from either from I0 or from I1, right? Let me name the output to be Y. So what the case here is, there are two inputs, there is a single output that is Y, but the condition is at a time we can take the output from I0 either I1, right? So for this condition, we are using a 2:1 multiplexer, right? So what the 2:1 multiplexer will do, it will basically multiplex these two parallel lines into a serial line. And this is done by the help of another pen that is called select line, right? So whatever the combination that I will be providing to my select line, according to that combination, my inputs will be chosen. Okay. Suppose I am providing my select line value to be 0. So at that time, my, one minute guys. So at that time, my I0 value will be chosen. One minute. Okay. Suppose I am giving the S1 value to be 1. Okay. So at that time, my I1 value will be chosen. Right. So for making this block, what we have done or what we have studied in our previous lectures, that my VHDL program will be having two basic parts, that is entity right, and the second part will be architecture. Okay, so by using the entity and architecture, by in a VHDL language, we can draw this, right? So for going further and making this design or making a 2:1 multiplexer by using the VHDL language, at first we have to understand one thing, that is known as signal, right? So what a signal basically defines, let me tell you or make you guys understand with the help of a diagram. Suppose this is a AND gate whose inputs are X and Y. This is the output of a AND gate whose input I am naming to be O, right? And there is one more OR gate whose input I am naming to be Z, and the another input of my OR gate I am naming it to be A. So here what we can see, the output of one of my gates is becoming the input portion of my second gate. So what the signal basically defines, A signal says that whenever the output of the first gate or whenever the output of any gate is becoming the input of another gate, that is known as a signal, right? So here in this particular diagram, what we can observe that the output of this AND gate was O, right? And that O output is becoming the input of my OR gate. Let me draw the OR gate properly for you guys. O, and this is A. Right? So basically, O was the output of my previous gate and the O is becoming the input of my next gate. So this is known as a signal. So here O is becoming my signal for this architecture, right? So let's proceed further. This is basically the architecture or the internal architecture of this particular 2:1 multiplexer, right? Here we can see that we are basically using 4 types of basic gates, right? That is a NOT gate, there are 2 AND gates, and there is a OR gate, right? So just few minutes ago I have told you guys that what is a signal basically. So what is a signal? A signal is the output of a particular gate which is becoming the input of another gate. So here also there are 3 signals which are S1, S2 and S3, right? The S1 is the output of a NOT gate which is becoming the input of my first AND gate, right? The S2 is the output of my first AND gate that is becoming the input of my OR gate, right? And the S3 is the output of my second AND gate and that is becoming the input of my second input of my OR gate, right? And here I have named the final output to be Y, right? And I am naming these 2 inputs to be I0 and I1, right? And this is basically, or this line will be basically the select line or the S line. So whatever the value I will be giving to this line, suppose I am giving the 0 value to this line. So whenever I am giving the 0 value to this line, whatever will be the value in my I0, that will be my output in the Y, right? And if I am selecting 1 in my select line, whatever is the value of my I1 input, that will be my final output of my 2:1 multiplexer, right? So what we have learned in the previous videos that for making any sort of a architecture, my entity and architecture definition in a VHDL language is the most important part, right? So here also, without wasting any time, let's jump on to the designing code, right? As already discussed in the previous videos, at first for writing any sort of a VHDL program, at first we have to define that what is basically my entity. So what we are defining in my entity, that let's show you guys by the diagram. What I am defining in my entity, that what are my input ports, right? What is my output port of the figure and what will be my select line of my figure. So here also we can see that after giving the entity name, that is gates, I am giving the two inputs, that is I0 and I1 as in standard logic. I am giving the select line name as S in standard logic, and I am naming the output to be Y as out standard logic, right? And then I am ending my entity portion by writing AND gates. Okay. So now the next part comes the architecture definition. So here in the architecture definition, as already discussed in the previous videos, at first, right after writing architecture, we have to give some name to my architecture that I have named to be behavioral, of my entity name that I have already named to be gates is, and then after, as we have just discussed that, here I will be using or I will be defining these inputs or these outputs of my gates to be signals. So here we can see that there are three signals, that is S1, S2 and S3, right? So the syntax for writing the signals is basically after writing the architecture or architecture name, we have to write the signals. So the syntax is we have to write signal and then the signal names that I have named to be S1, S2, S3 and then semicolon and then standard logic and then ending it with the semicolon, right? So here in this line, what I have told to the compiler that there will be three signals, like there will be three outputs of my gate which will be made as a input of my another gate, right? And then I am again starting my program by writing begin. So what I have done in the first step after writing begin, that I have made the S1 signal equal to not of S, right? Let's understand this by seeing in the diagram. Wait a minute, guys. What I have done in the first step, I have made S1 is not of S, right? So what I have already done, I have named this one to be S1. So what I can see that basically S is becoming the input of my NOT gate. So what my S1 is becoming, my S1 is becoming not of S, right? So that's why I have written S1 is equal to not of S, right? And in the second line what I have done, S2 is equal to I0 and S1. Let's see in the figure, right? I have named this to be S2, right? So what this S2 is coming from, this S2 is coming as a output of my first AND gate. So what are the inputs of my first AND gate? My inputs of my first AND gates are coming to be I0. So I0 is becoming one of the inputs of my AND gate and S1 is becoming one of the inputs of my AND gate, and the output of my AND gate I am naming to be S2 as a signal, right? So in the coding part also I have named the S2 to be I0 and S1. Okay. In the third step what I have done, I have written S3 is equal to I1 and S, right? So what is happening in the third line? Suppose this one I am naming to be S3, right? This one I am naming to be I1, okay? And this one is the S value, okay? So what I am doing here, in the third line, I am writing I1 and S, right? So here we can see that the S3 is the output of my second AND gate and I1 and S are the inputs of my second AND gate. right? So what we have defined till the third step, we had defined the outputs of my two AND gates to be S2 and S3. So after defining the S2 and S3 signals, what is the next step that we can see? That in the next step we are having a OR gate. And what are the basically two inputs of my OR gate that is coming? S2 and S3 are the two inputs of my OR gate. So here also in the next line, I will be writing Y is equal to S2 or S3. Okay. Here S2 and S3 are the two inputs of my OR gate. Okay. So that's why I have performed the OR function of my S2 and S3 and I have assigned the result to my Y. Okay. So here what the Y output is giving. Here after performing this whole function, my Y output is giving my final output of my 2:1 mux, right? So here after defining the architecture portion, we are ending our architecture. So that this sums of our block design, right, by using the entity and the architecture. Let's see in the software how this is coming, right? Here in the software I have defined the entity name to be gates, and then after I have defined the ports that are I0 in standard logic, I1 in standard logic, S in standard logic, and Y out standard logic. And then after I have ended those gates, and then after I have started naming the architecture, whose name I have given to be behavioral, and then I have called my entity portion here, and then after I am defining the signals, which I have told you few minutes ago, and then after the beginning portion, I have started to tell my compiler that what are the functions that I am going to perform or I want to perform. And then after defining all this, I am ending my architecture, right? Let's see the block. You guys can see here, no? Here the block I am getting, is it same as the block that I have shown you guys few minutes ago? 1 minute, I am erasing this so that it will be more clear for you guys. Here after writing these statements or these steps, am I getting this block in my software as well? Yes or no? Just put down in the comment section. I'm getting it, right? So here I have basically got my architecture of my 2:1 multiplexer by using the VHDL language. So now I have got the architecture, but I also want to check that whether this particular architecture is performing the function of a 2:1 multiplexer. Okay. So what will be the condition of my 2:1 multiplexer? Let me erase this and tell you guys. The condition for my 2:1 multiplexer will be whenever my select line value will be, let me name this block to be S and let me name this block to be Y. Whenever my select line value will be 0, at that time whatever is the value in I0, that should be coming in Y. Whenever my select line value will be 1, whatever is the value in I1, that will be the answer in the Y, right? So for this situation, this particular situation, what I have to do? put down in the comment section what I have to do if I want to verify this. For verifying this, as I have already discussed in my previous video, we have to design a test bench. Okay, so let's see the syntax for writing a test bench. This is basically the syntax of my test bench, right? Here, as I have already told you guys that in case of test bench, we just don't need to define anything in the entity portion, right? And then again, in the architecture portion, we have to give a particular name to my architecture of, then after we have to call our entity is, and in the next line, as I have already discussed that in case of test bench guys, what we have seen in case of architecture designing, we were naming the outputs of my gates which are becoming the inputs of another gates to be the signals. But in case of test bench writing, whatever will be the inputs or whatever will be the entity portions that I have defined in my diagram definition or the architecture designing part, that those things are going to be my input or those things are going to be my signal in case of a test bench, right? So here in the signal portion of the test bench, you guys can see no that I have given in the entity portion I have given I1, I0, S and Y to be my input output ports, right? So here also in case of test bench, I am writing I0, I1, S and Y as my signals, right? And I am giving it to be standard logic 0, right? And after writing the begin statement, I am again calling the UUT statement that is known as unit under test. Here what we are doing, here basically I am calling the entity portion or the entity in my test bench that I can see that in the architecture in the designing portion I have named my entity to be gate. So here also I am calling my gate entity which will be under a test. Here gates is becoming my unit that will be under a test, that we will check that whether I am getting the combinations of input output according to our truth table or not, right? Entity.work.gates port map, and you guys know that what is a port map. As I have already told you people, I am naming it to be the input ports to be I0, I1, S and Y, and then after I am initiating my process by writing tb.process, that is testbench.process, and then I am beginning to give my input output values of my 2:1 multiplexer, right? Here what I am seeing that whenever the value of my S is coming to be 0, whatever the input of my I0 is, that should be coming in my Y, and when I am giving the S value to be 1, whatever the value in my I1 is, that should be coming in the Y. And I have already told you people that why I am writing this wait for 2 nanosecond statement, right? And then after writing or providing these two combinations, I am ending the process that I have started or I have initiated in the beginning, and at the very last I am ending my architecture portion also. Okay, so I think you guys have understood the test bench portion also. So let's check that in the software as well. Run behavioral simulation. Wait for a few seconds. Okay, let's zoom it. See guys, at the initial part, my S value is 0, my select line value is 0. So whatever is the input in my I0, that is coming to be my output in the Y portion. Let's verify this. When my S is 0, select line value is 0, whatever the output or whatever the value will be there in the I0 portion, that should be coming in the Y portion. Okay, so first statement has been verified, right? Let's check for the second statement. In the second statement, here we can see that my select line value is 1 and whatever is the value in my I1 pen, that is coming to be my output, right? Let's verify that also. Here what we have seen, whenever the value of my S will be 1, whatever the value will be there in my I1, that should be coming in my output Y. So this is also verified. So guys, what we have seen that in case of a 2:1 multiplexer, whatever the input combination that we are providing to my select line, according to that only we are getting the output here. Okay, so I think you guys have understood that how we can make a 2:1 multiplexer by using the basic gates, or you guys can just pause this video for this particular structure. Okay, or else you guys can easily find any sort of a block diagram of a 2:1 multiplexer from Google and just draw that block diagram in your particular on a piece of paper. Just name those signals by a pen and then start making the diagram or start making the program just by making the diagram into few parts. Like if you guys are making the diagram part by part, then it will be really easy for me, and this is a suggestion from my side, right? So that's all for today's video, guys. I think you guys have understood, and if you people like the video, please don't forget to like, share and subscribe because your support is really needed. And thank you.